kinetic energy. So this total work done on the body will impart a kinetic energy to it. So what was the total work done? Gmm by r, that must be equal to the kinetic energy of the body, where it possesses a velocity, what we call it as escape velocity. Copy down, boys. VE, this is the second part of your derivation. First part you completed with the total work done in moving the body from the surface to infinity. Now that has to be equated to the kinetic energy. So that is why when you go for your professional course, you will like your subject more than what you do here. Here it's totally theoretical. So there it will be most of the time it will be practical. Same. Yeah. It's most of you will be having practical. That is why we always insist to your students to go for the good engineering courses. Engineering colleges where your lab facility should be good enough. Your marks will fetch you over there. Now get me an expression for VE. Joshua, microphone is on. Sorry. Sorry. Okay. Yusuf is in this class. Yusuf, what is the value of VE? What is an expression for VE?
Ma'am, can I say?
What is the value of VE? What is an expression for VE, boss? Yusuf. Harish. Harish is in your class, right? Harish.
Yes. Yes.
Harish, what is VE?
Root 2gm by r.
2gm by r. Okay. Now I want to replace. Now how will I replace gm?
With
So
g,
since,
right?
okay, acceleration due to gravity, g is equal to gm divided by r squared. So what is gm now? Gr squared?
Yes, ma'am. So it will be root 2gr.
Correct. That becomes 2 into gr squared by r. So VE becomes equal to root of 2gr. This is the escape velocity. Now, does it depend on the mass of the body?
No, ma'am.
Evidently, no, ma'am.
Okay. So copy down. You can write the statement. It is independent. I think so. I'll go for numerical rather than going and taking a new topic today.
Ma'am, this G
Yes, boys.
is the Earth, right?
VE is the escape velocity, boys.
No, ma'am. G here is acceleration at the surface of the Earth, right?
Yeah, acceleration at the surface of the Earth. And please understand, your VE depends upon acceleration due to gravity. On the surface of Moon, your G, the value of G is 1/6 the value on the surface of the Earth. That is why Moon is not having an atmosphere. Boys, the what to say? Your reasoning-based questions are based on this. All your reasoning-based question might be based on this concept. Why can you account for no atmosphere on the surface of moon? Because the value of G is very less. So in that case, what happens? The escape velocity is very less. Bodies can easily escape from the surface of the moon. So you can expect a reasoning based question. The final expression. Thank you. We'll go for numerical on orbital velocity. I'll read it out. Boys, those who haven't copied, please put a. You want to take a screenshot, you take the screenshot and put, or else can someone take the screenshot? Yes, boys. Now I'll read out the question. Please do write. This is based on orbital speed. Right. An artificial satellite. An artificial satellite revolves around the Earth. An artificial satellite revolves around the Earth at a height of 1,000 kilometers. At a height of 1,000 kilometers. The radius of the Earth is 6.838 into 10 to the power of 3 kilometers. Mass of the Earth is 6 into 10 to the power of 24 kilograms. And your gravitation constant is 6.67 10 to the power of minus 11 newtons meters squared per kilogram.
Ma'am, what's that G? Ma'am, after mass of the Earth?
Gravitation constant. It remains constant anywhere in the universe. Okay, gravitation constant. Now the question is, all these factors are being given. Now what you need to find is, find orbital velocity first. Find orbital velocity. Second one, you have to find period of revolution. Since I have not derived an expression of period of revolution, we'll do it along with this numerical. Period of revolution. Period of revolution means time taken to complete one full revolution. We call it as period of revolution. So first we'll start with orbital velocity. Which formula will you use, boys? You have different. See, what is the formula for V0? Just check your orbital velocity. Can you check, boys? Okay, VC is, since you cannot neglect height, V is equal to root of GM or what? Can you turn your page and check for yourself?
Ma'am, root of GH into R plus H.
GH, G capital M by R plus H?
Yes, ma'am.
Okay. Because you cannot neglect, boys, the values of G and M are being given. So we are utilizing this. If anyone wants to find, what will be the other formula?
G times R plus H.
That will be R squared. So R squared might be tough for you. Just check how you can proceed. Boys, what you have to do is look at this. R is having a power of 10 to the power of 3. I can write this as 10 cube meters then you can, this is 1 into 10 to the power of 3 meters. R is 6.38 in 10 to the power of kilometers. So what should I do? Kilometers should be converted to meters. Boys, how will I find R? R is 6.38 10 to the power of 3, or I can write 10 to the power of 6 meters, because so now R becomes equal to 6380 into 10 to the power of 3. Is that fine what I am writing? Just check, boys. Why I am putting it in the form of 10 to the power of 3? Why not 10 to the power of 6? Because you have to add the value of h. H is this correct what I'm doing? Just check, is this correct what I'm doing? No, is this 6? Yes, is this 6, right? Is it not? This is 6. Is that not? That is 6. Then in that case, I need not have this. Boys, are you clear? How can I write 1000? 10 to the power of 3. How can I write, so how can I convert kilometers to meter? 10 to the power of 3. So 10 to the power of 3 into 10 to the power of 3, I'll get 10 to the power of 6. Is that clear, boys?
Yes, ma'am.
Okay, now you substitute and get me the value of VC. What is the value for VC, boys? Jopal, what is the value you are getting? Okay, no. So what will be the value? Should I do, boys? I'm just asking you because you people have started solving numerical using your exponentiation. Should I do this?
Yes, ma'am.
4.7. Okay. Let me check. I'll do this because I think so. You people are struggling. G is 6.6. Okay. I'll make it whole number. If you people are finding it difficult, I'll just right now I'll make it whole number. 6 into 10 to the power of minus 11. Correct. Mass of the earth is 6 into 10 to the power of 24. I'm just rounding it up. Now R plus H, was this will be R plus H will be equal to 6.38 plus 1 into 10 to the power of 6, was correct? So what is that? 7.38 into 10 to the power of 6 meters. Fine. Even here I'll round because if you are finding it difficult, I'll round it over here. So I'll make this as 7. 7 into 10 to the power of 6. 7 is fine. Now how will I find this?
Ma'am, the numerator will be 6 into 10, 10 to the power 13.
Okay. 6 into 20. Okay, fine. But 6, let me go for with this one. That is 6 into 10 to the power of 13. Okay, plus 13. 10 to the power of minus 6 divided by 7. Correct? Is that not? I'm getting this. Okay. Now, what we need to do is you have to just make it a whole number. So 10 to the power of, it becomes minus 7. Sorry, plus 7. So you can keep it as 10 to the power of plus 6 and just make this as 360. VC, I can make this as 36 into 10 to the power of 7 divided by 7, or I can make this as root of 360 into 10 to the power of 6 by 7. So this 10 to the power of 6 will come as 10 to the power of 3. So VC becomes equal to 10 to the power of 3 divided by 360 by 7. So 360. Okay, 7, 5, 35, 10.4, 5. Okay, 5.14. So VC becomes 10 to the power of 3 into square root of 5.14. Now, boys, suppose if I take 2 squared is 4, 3 squared is 9. So somewhere between, it would be very close to 2.
Ma'am,
Very close
you
to
could
2.
just take out 6 out of the root here. When it's
Yeah,
360.
360 also you can, yeah, you can take it as,
Ma'am,
or
won't
else
it
you
be
can make,
51.4?
sorry, boys, 51.4. So 51.4 in that sense, your square root will be somewhere around 7, yeah, 7 is 49,
Yes,
8
ma'am.
is 64,
Around 7.
somewhere around 7. So you have to judge this way and do, otherwise you go for long division method. So 51.4, somewhere around 7 point. See, last digit is 4, 7.2 to 7.2. Yeah, because last digit is 4. Somehow you balance. So I'll approximately take it as 7.2.
Ma'am, 7.16.
16, okay, fine. 10 to the power of 3 meter per second. Yeah, correct. 7 point.
Yes, ma'am.
Now you people should be solving the numericals using the exponential form. It will be easy, and just here and there you have to manipulate and take the values. Fine, boys. Now we'll go for time period. Boys, I don't know. Now we'll go for the time period, right? Suppose the satellite is revolving around the Earth. So you have the satellite. So the satellite is having a mass m.
Ma'am, could you the last slide? I'll
The
just
radius.
screenshot it.
What?
Ma'am, can I screenshot the last slide?
Last one?
Ma'am, the previous slide.
I think it's
Okay. Oh, okay. Sorry. I'll take it from the recording.
Now, what will be the time period was? Time period means what? The time taken for one complete revolution. What is velocity? You just come back for what is velocity? Velocity is distance by time. The satellite is revolving with a velocity v0 or vc, right? So in one complete revolution, what is the time taken? Complete revolution. Time taken is your time period. That is your time period. Okay, what will be the distance traveled in one complete revolution? How will you find? Suppose you take it as circular orbit. If you take a circular orbit, what will be the distance traveled? Yeah. Right? No, not in terms of angle. No.
Ma'am, arc, circumference.
Circumference. What will be the circumference, boys?
2 pi r.
2 pi r. Okay. So distance in one complete revolution, time taken is time period. Distance traveled will be equal to 2 pi r. See, this is all approximation. None of the orbit is circular, boys. All the orbits are elliptical. When you are learning for beginners, always we go for circular orbit, and then we'll move on for elliptical one. We always go for a circular orbit, so 2 pi r. So velocity vc will be equal to 2 pi r divided by t. Please copy down, boys, because I haven't Boys, I haven't derived an expression for the time period. So just write the subheading, time period of the satellite. Time period of the satellite. So in one complete revolution, time taken, t is equal to the time period, distance traveled will be equal to the circumference. So VC becomes equal to 2 pi r by capital T. Now, what is that you require? T is equal to 2 pi r divided by VC. So what is the formula for VC over here? Because you are being given the value of, so you have to replicate it. What was VC in the previous numerical? I'm not talking. Okay, if you, or else you substitute the values. Formula you know how to put, right? If they ask you to derive an expression, you have to put the value for VC. Fine words. Now you calculate this. Boys, are you doing the calculation?
Yes, ma'am.
So this becomes 2 into 3.14. What is the orbital radius? The radius of the Earth is 6.38. If you want, you can make it a 6.4. 10 to the power 2 kilometers divided by your VC was 7.3. I'll just write it as 7.3 10 to the power of 3. Correct? Was that so? Was
Yes, ma'am.
just it will be in seconds.
And we are rounding the radius of, yeah.
Yeah, you can round. No, I'm just right now. I have to move, finish this numerical faster. So I'm just. Or else
Ma'am.
you can easily. No, boys, you can easily. Yes.
Ma'am, if you have to derive the formula for time period, which
Formula. What you wait, boys? Formula. In that case, you have to put the value of VC.
ma'am, so which formula of VC would we use?
That depends upon the values that are being given. Anyway, tomorrow I'll just.
Ma'am, is the answer 5.488?
Just check, boys. 5.4. It's showing 6.2. No, 6297. Just check. Boys, sorry, boys. This is kilometers. We have not converted to meters. Fine. Then in that case, tomorrow continuing this numerical. What we'll do is we'll just once again go back for finding the expression for the time period, then the height of the satellite, and then we'll do one more numerical on height of the satellite. Just calculate, boys.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Ma'am,
Yes. I'll
ma'am,
send.
you talk to Mani, ma'am.
No, I'll speak to her today. Today evening, I'll speak, and then I'll give you. I'll ask her whether you can take.
Okay, ma'am.
Put a new team and move. Okay. Fine.
Ma'am, I can just
I'll
do it in physics, yeah.
Physics itself, fine. I'll just ask.
Thank you, ma'am.
Thank you,
Ma'am,
boys.
you just talk to her.
Thank you, ma'am.
I'll talk to her. I'll talk to her and I'll send you the message.
Okay.
I'll ask someone to help you out. 2 of you can coordinate. I'll ask someone to help.
Ma'am, I have to do on work, energy, power, and only 5 numericals, so I'm fine.
Yeah.
Hello.
Oh, yeah, fine. Okay. Fine.
Thank you, ma'am.
Thank you, boys.